Hello everyone, welcome back to e-classes of Statistics Standard 11th. In this video, we are going to do sums related to mean deviation. So let's have a look on the formulas of mean deviation of ungrouped data and grouped data. For ungrouped data, mean deviation is equals to sigma absolute x minus x bar upon n, where absolute x minus x bar is the difference between observations and the mean, and n is total number of observation. For grouped data in discrete frequency distribution, the formula is mean deviation is equals to sigma f absolute x minus x bar upon n, where x bar is mean and x is the observation, f is frequency, sigma f or n is one and the same thing. Continuous frequency distribution, the formula is mean deviation is equals to sigma f absolute x minus x bar upon n, where x bar is mean, x is mid value of the classes, f is frequency of the class, n is total of frequency column or sigma f. And the formula for coefficient of mean deviation is md upon x bar. Now let's do the sums related to mean deviation from exercise 4.3 of your textbook. Sum number 1 from exercise 4.3. Let's read it. The measurement of height in centimeters of 10 soldiers are given below. 10 soldier means here n is 10. And this is the data given, ungrouped data. Find the mean deviation of the heights of the soldiers. Let's solve the sum and be more clear. So here we have prepared the table and we know n is 10 in this sum, and first we are going to find absolute sigma x minus x bar. For that we are going to find x bar, that is mean first. X bar is equals to sigma x upon n. So we'll total this column of x. We'll get the sigma x, that is 1674, and n is 10 divided by 10. So we get 167.4 centimeter. So x bar is 167.4. Now x minus x bar, that means 160 minus 167.4, that gives you 7.4. Then 175 minus 167.4, that gives you 7.6. And 158 minus 167.4, that gives you 9.4. Now 158 minus 167.4, that gives you a positive value because absolute is given here. So all are positive values here. Then 165 minus 167.4, that gives you 2.4, and so on. And if we total this column, we'll get the sigma absolute x minus x bar is equals to 50. Now we'll put the value of absolute x minus x bar in the formula. Let's solve and be more clear. So here is the formula of mean deviation, that is sigma absolute x minus x bar upon n, and we have put the values in that. We have totaled the sigma absolute x minus x bar, that was 50, and n was 10. So 50 divided by 10, that gives you 5 centimeter. So your mean deviation is 5. Now let's solve sum number 2. Let's read sum number 2. The distribution of number of ball bearings used in machines of a factory is given below. Calculate the mean deviation and coefficient of mean deviation of number of ball bearings. Here you have to find both mean deviation and coefficient of mean deviation. Here the data is given in a discrete form. Number of ball bearings and number of machines is given. Let's solve the sum and be more clear. So here we have prepared the table. We have written here number of ball bearings, that is x, number of machines, that is frequency f. So first we are going to take out fx so that we can know the mean. So fx is 2 into 2, that is 4. 4 into 2, that is 8. 6 into 4, that is 24. 8 into 5 gives 40. 10 into 3 gives 30. 12 into 2, that's 24. 14 into 1, that's 14. 16 into 1, that is 16. Now sigma fx is 160, and n is 20. So frequency sigma f is 20 or n is 20. Now we'll find the mean first. So x bar is equals to sigma fx upon n, that is 160 upon 20, that gives you 8 balls. So mean is 8. Now we are going to find absolute x minus x bar. As x bar is 8, this is your x. 2 minus 8, that gives you 6. 4 minus 8, that gives you 4. 6 minus 8 gives you 2. 8 minus 8 gives you 0. As all the values are coming positive, that is because of absolute. So 10 minus 8 gives you 2, and so on. Now we are going to find f into absolute sigma x minus x bar. This is f column, that means 2 multiplied by 6, this will give you 12. Then 2 multiplied by 4, this will give you 8. 4 multiplied by 2 will give you 8. 5 multiplied by 0 will give you 0, and so on. So here we get sigma f absolute x minus x bar, that is 56. Totaling this column, we get 56. So absolute sigma f absolute x minus x bar is 56, n is 20. Now let's put the values in the formula and solve the sum. In this sum, we have to find both mean deviation and coefficient of mean deviation. And the formula for mean deviation is sigma f absolute x minus x bar upon n, that is 56 upon 20. That gives you 2.8 ball bearing. Now coefficient of mean deviation of ball bearing, and the formula is md upon x bar. Here md, you can see it is 2.8, and x bar that we have already taken out, that was 8, that is mean. X bar means mean. So 2.8 divided by 8, that gives you 0.35. So we have done this sum. We have taken out mean deviation and coefficient of mean deviation. Go through the sums, revise it thoroughly. Thank you.